Hello everybody, Carl Larson here with a two-part tutorial series on tracking the position of a parented layer in Adobe After Effects. In the first part, we'll be going through the background of why this subject is important and how we actually track a child layer. In part 2, we'll be putting our knowledge to use and making a really great looking title build using child trackers. So, let's get to it. The first thing we need to discuss is parenting in After Effects, and really the concept's pretty simple compared to the real-life alternative. Simply put, parenting in After Effects is the process of synchronizing the transform attributes of one layer to another. So, for example, a parent layer can drive the position of a child layer, or its rotation, or if it's a 3D layer, it can even drive its orientation. The only transform property parenting does not affect is opacity. That's just the way it is. Additionally, a child layer can move freely in relationship to its parent, but if a parent layer moves, all the children come with. So yeah, parenting is a really powerful function in After Effects. To further demonstrate how this works, let's set up a really basic model of our solar system, with a sun, a planet, and a moon. To begin our project, we'll create a 2000 by 2000 pixel composition, new composition, and just like in our world, the sun will be placed at the center, the planet will orbit the sun, and the moon will orbit the planet, which orbits the sun. To do this, we'll need a couple of nulls and some solids. We'll use the nulls to drive the motion of our solar system, and the solids to represent the planets. So, layer, new, null object. Name the layer pivot, and this will be the point about which our entire solar system rotates and where we'll put the sun. Now duplicate the layer and rename it to R1. To rename a layer, simply select its name, press Return or Enter on the main section of the keyboard, and type in the new name. This will be the null that we'll use for our planet. Next, duplicate R1 to get R2. This will be the null that drives the motion of the moon. So now we have a central pivot and two rotation points. But currently they're all in the same place. Grabbing all three layers, press P on the keyboard to reveal their position properties. Since our composition is 2000 by 2000 pixels square with 0, 0 located in the upper left-hand corner, the position of the nulls are, not surprisingly, located at 1000, 1000 on the composition's coordinate system. So let's move them into position. Leaving the pivot null where it is, let's move R1 to 1475 on the y-axis and R2 to 1750 on the y-axis. To make our solar system work, we want the motion of the inner objects to drive the motion of the outer objects. So R1 will get parented to the pivot, and R2 will get parented to R1. That way, when we spin the pivot, R1 will travel in a perfect circle around its parent. Likewise, when we spin R1, this will cause the moon's null, R2, to orbit the planet in a perfect circle. But before we do that, let's add some motion to our scene so we can have a better idea of how the final planetary motion is going to work. So selecting all three layers in the timeline, let's press Shift-R to reveal the rotation properties of the layers while keeping the position properties visible. To get our world rotating, click on the rotation stopwatch of the pivot null, and then move to the end of the timeline to change the value to 1 revolution. So now that we have the pivot point rotating, let's parent R1 to the pivot. Just as we expected, R1 now orbits the pivot point. But notice what happened to the position coordinates of our layers as we parented them together. Instead of displaying the position of the layer relative to the world of the composition that it's in, R1, the child layer, now displays a position relative to its parent. The layer itself doesn't move on screen when we initially parent them together, but it's now using a different relative layer space to describe its current position. Just to make this really clear, let me say it another way. When we parented R1 to the pivot, the description of its position changed from 1000 on the x-axis and 1475 on the y-axis to 0 on the x-axis and 475 on the y-axis. The child layer no longer defines its position by its relationship to the origin of the composition, but instead by its relationship to the parent layer. And since the rotation of the pivot is driving the motion of R1, even though it's now moving around the composition, R1's numeric position values aren't changing because all the movement is being driven by the animation of the parent layer. This concept of relative layer spaces will become very important in a little bit. But for now, let's continue setting up the rest of our scene so that we have a little more motion to work with. So to get R2 to orbit R1, let's begin by writing a quick expression for the rotation of R1 based on the rotation of the pivot. Option-clicking on the rotation stopwatch for R1, Pickwhip to the rotation parameter of the pivot, and then multiply the value by 2. This will make it so we have 2 orbits of the moon for every orbit of the planet. And I've used an expression here instead of keyframes so that if we make any changes to the rotation of the pivot null, the rotation of R1 will automatically be updated. Finally, parent R2 to R1. Now that we have the basic motion of our solar system set up, let's add some planets to the scene. Layer, New, Solid. Make it 100 pixels by 100 pixels and choose a dark red color. Next, double-click the elliptical mask tool to get a perfectly circular mask on our layer. There, now we have our sun. Now duplicate the layer 2 more times, Edit, Duplicate, or Command or Control D on the keyboard to get some additional layers for the planet and our moon. Just to keep things organized, let's change the solid settings of the duplicate layers so that each one has a different color. That way it'll be easier to tell them apart. Layer, Solid Settings. That's Command-Shift-Y on the Macintosh, and choose a separate color for the planet and the moon. Now let's get our planets connected to the nulls. Technically, the sun isn't going to move, but just in case we'd like to do that later, we might as well parent it to the pivot now. Let's do the same thing for the Earth and Moon. So the Earth layer gets parented to R1 and the Moon gets parented to R2. Now let's move both layers to 0, 0 respectively so that they sit right on top of their individual parent nulls. Now to get a circle tracing out the orbit of each layer, let's duplicate the Sun layer and select the lower copy in the layer stack. Press S on the keyboard to reveal the scale property and scale it up until it intersects with the path of the Earth. And before I go any further, I'm going to change the solid settings of the layer to a gray color so we can see what we're doing and keep our timeline organized. To eliminate the pixelation that occurs, we can turn on the collapse transformation switch in the timeline so that After Effects always calculates a vector result for the solid. Finally, let's go to Effect, Generate Stroke to put a stroke around the edge of our circle. Since we already have a mask defining the circular edge of our layer, all we need to do is change the paint style to On Transparent and turn up the brush size a little bit. To make a path for the moon orbit, let's start by duplicating the Earth orbit layer and changing the name to something more appropriate. Next, parent the layer to R1 and change its position to 0, 0. Now we'll just scale down the layer a bit until it matches the size of the moon's orbit, and there we go. Now we have a great looking miniature solar system, but how are we going to track the position of the moon layer now that it's parented to our chain of nulls? Well, actually we can't. At least not directly. If we were to create a new layer and apply the right-on effect to it in hopes of tracking our moon, we'd get a stationary result. That's because the child layer itself isn't technically moving. But let me show you how many, including myself, have attempted before to do this unsuccessfully, and then we'll get into how to correct it. First, create a new composition-sized layer. Layer, New, Solid. Name the layer Tracer and make it comp-sized. Choose an obnoxious color just for fun, and click OK. And then go to Effect, Generate, Right On. Then change the Paint On style to On Transparent. Next, select the layer we want to target, the moon in our case, and press P on the keyboard to reveal its position property. In the Effect Controls palette, Option or Alt-click on the brush position stopwatch. This will enable an expression in our timeline. Then, simply Pickwhip from the right-on effect to the position parameter of the moon layer. Now turn up the brush size so we can see what we're doing, and we get nothing. But clearly the layer's moving. Why can't we just track it? Well, remember, when we parented our layers together, our nulls underwent a layer space transformation. Once they were parented, the nulls stopped looking at the comp for their position, but instead began describing their position based on how far they are from their original parent layers. Which means that we need to somehow get our original layer coordinates back to make the expression work. To do this, we'll use a layer space transformation expression. But don't let that scare you. We'll only be writing 2 lines of code. And in fact, I can't take credit for either of them. According to my research, which could very possibly be incomplete, Michael Natkin of the Adobe After Effects team was the first person to publish an expression used to track the position of a child layer. He said this, which in English means that we need to define a variable, which he calls C, stating which layer we want to track. Next, we use the coordinates of C and transform them to our comp, using toComp, based on the position of the anchor point of the layer. And if we type that in and modify the name of our layer to match, it works beautifully. But after digging around a little bit more on the subject, I discovered that Dan Eberts, sometime after Michael's expression was out, also wrote a very similar expression in response to a question on the Creative Cow After Effects forum. He said the best way to track a child was this. L, our variable, which I'm assuming is shorthand for layer, equals whatever layer we want to track. And P, which I'm assuming stands for position, equals the coordinates of our layer translated into our composition's world using the toWorld function. And all of this is based on the anchor point of the layer that we want to track. Basically, they're both saying the same thing. The only difference is that the toComp function is a 2D result and the toWorld function gives a 3D result. And in my experience, when I've played with it, the toWorld function has worked just fine when I needed a 2D solution. It just ignores the z-value. So I suggest always using the toWorld function, and then you only have to remember one expression. And if it gives you any problems, now you know about the toComp function, and you can use it if you need it. But before we type any of this in, let me show you the way that I like to do it. Because, to be honest, I'm a terrible typist. In fact, I got a D in my keyboarding class back in 8th grade, and it's pretty much scarred me for life. So I like to use the Pickwhip as much as I can when I write an expression, even if the code gets a little more complicated. It's just a way that I can be sure I don't misspell anything, and it makes it less for me to remember. So back in our timeline, grab the layer we want to track and press A to reveal the anchor properties of the target layer. Next, select the tracing layer and option-click on the brush position stopwatch in the Effect Controls palette to enable an expression. I'll type C equals, and then grab the Pickwhip and drag to the name of the layer I want to track. Then add a semicolon to the end of the variable. Next, I'll type C dot to capital W world, open parentheses, and then Pickwhip to the anchor point of the layer I want to track. Close the parentheses and add a semicolon for tidiness sake, and we're all done. Again, you could type it in and have a little more compact code, which might be easier for someone else to read, but I'm just showing you how I like to do it to be sure I don't end up with a typo in my expression or forget how to write it. You do what works for you. Anyway, now that we have our expression hooked up, let's see how it's working. Perfect. Now after all that explanation, was it worth it or what? Okay, yeah, maybe the result wasn't super impressive, but remember, you can take this and apply it to any parent-child setup no matter how complex. For example, what if we wanted to trace the motion of the moon of a planet orbiting the sun? Well, with the addition of a couple more layers and without modifying our expression at all, it'll still work. What if we wanted to trace the motion of a moon? Yep, we could do that too. In fact, since we're using the toWorld transform function, we could even have it trace the motion of multiple objects parented in 3D space, and have it trace out a fully 3D path. How cool is that? We'll play with the possibilities more in part 2 of this tutorial series. Well, there you have it, an introduction to tracking a child in After Effects. Be sure to check out part 2 of this series, where we'll continue where we left off and build some really great motion graphics using our newfound knowledge. So until then, I'm Carl Larson for CreativeCow.net.